The CLO for this lesson is that students will be able to graph in writing functions using parent functions and transformations, as well as the following language, if-then statements: parent function, transformation, and translation. In your own words, what do you think you're going to learn how to do in this lesson? So quickly, to start with the vocabulary, what is a parent function? Remember, the parent function is the main one, and it's there to show us the shape and how that type of function acts. And then what is a transformation? Remember, transformation's a way we can change a shape, so we can change the graphs and equations with transformations. And then what's a translation? Translation was one of the transformations. It's the one that means we move it. So we learned in the last lesson that you can move things up and down. So that was one of the translations. For this lesson, for part 2, it's about translating it left and right. So the transformation we're going to work on first is translating left. So to answer the question, what causes a function to translate left when we're in an equation? The answer is, as weird as this is going to be, it's a number added to x inside of the function. So if a number was being added to the outside, it would be up. But when it's inside, it's left. Now that's kind of weird because when you think of going plus 3, that's to the right 3. So you might think this means go to the right, but it doesn't. It's like when it's in the parentheses, it's the opposite of what you think. And I'll explain that in a second. But let's first try to graph it. So what's the parent function for this guy? This is an x squared graph because of the exponent of 2. So it's a quadratic. So for the parent function, if I plug in -1 and square it, so times it to itself, -1 times -1 becomes +1. 0 squared becomes 0. 1 squared is 1. So if I go to my original x squared graph, the 3 dots are right here. Then if I plug it into here, -1 plus 3 squared. Well, -1 plus 3 is 2. And 2 squared, 2 times 2 is 4. I plug in 0 plus 3 squared. 0 plus 3 is 3. And then 3 squared, 3 times 3 is 9. If I plug in 1, 1 plus 3 squared. 1 plus 3 is 4. And 4 squared, 4 times 4 is 16. So these 3 x's in this new graph are going to look like at -1, I went up to 4. By 0, I was all the way up to 9. And then by 1, I'm going to be all the way up to 16, wherever that is. So if I connect these, you see how none of them's Uing yet? And if it keeps going down, it's going to kind of U over here. So if you remember with quadratics, when I was trying to find my new vertex from this, it would be the opposite of in here, what would make this equal to 0, which is -3. And that's where the vertex would move to, my little hump. So it's not going to go right 3, it's going to go left 3 over to -3. Because who cares for the parent function, but for the f of x, when I plug in -3, then add 3, -3 plus 3 is 0, and then 0 squared, 0 times 0 is 0. So this is where my vertex will be. which means going around it, -2 and -4. If I plug in -2, and then I add 3. -2 plus 3 is 1, and 1 squared is 1. So at -2, there's a point at 1. And then for -4, the equation is x, so -4 plus 3. -4 plus 3 is -1. And then we're supposed to square it, and -1 squared is +1. And so you can see that this equation shifted to the left 3 for a new graph. So because it's in the parentheses, it does the opposite of what we do. So adding makes it translate to the left. Um, so when I look at this and I see the +3 inside the parentheses getting squared with the x, I know my transformations then is to translate left 3. I would have had to identify in the situation that my parent function is the x squared, which is a quadratic. And the shape quadratics make are the parabola, that little U shape. So then, just by knowing this from the equation, I could have quickly graphed it by skipping the table and just take my vertex, left 3, put a new vertex, and then remember with quadratics, if you remember when we graphed, these were our major points to plot for each one. So for the quadratic, it's the vertex at 0, 0, but we translated it based on the transformations. So we went left 3. Then next, it's right 1, up 1 from that new vertex. Right 1, up 1 was that point, and then the left 1, up 1 was that point, and then you make your right shape. And that's the quick way to graph. So if they wrote it differently, and they were writing the shifts with notations, they would have said that f of x, the parent function, is x squared. And they would have said to graph f, and then the +3 is in the parentheses with the x for this notation. It's not at the end, because if it was at the end, it would mean if the parenthesis was here and the 3 wasn't in the parentheses, this is up 3. But being in the parentheses with x, where the function is happening to that 3 as well, like the 3 is getting squared as well, because it's in the parentheses with the x, then that is what means left 3. So if we do another example, but this time more quickly, if you look, there are 2 transformations in here. So first of all, let's start here. What is the parent function for this one? Parent function, those 2 little lines, remember, is absolute value. And the absolute value makes which shape? Absolute value makes the V shape. So the transformations that are not this absolute value, what's there besides this, is the +5 and the -2. What does the +5 mean? Because it's in the absolute value with the x, it means go left 5. So being inside the function with it is translating left 5. And then what does the -2 at the end mean? Remember, if it's at the end and it's negative, it's meaning translates down 2. So if I were to graph this quickly, my absolute value graph starts at 0, 0, the vertex. But I'm going to go left 1, 2, 3, 4, 5, and then down 2. I have to do both things for my new vertex. Now from the new vertex, for all of them, you go right 1, up 1. And then for left 1, it can either be up or down. But since it's absolute value, if we look at those major points to plot, absolute value is left and up to make that V shape. So it's going to go left and up right here. from that new vertex, left one, up one. And then I make my correct shape, which is a V. And that's the absolute value graph. It should be a better V. I didn't draw my lines as straight as I should have. If they were trying to write this equation in a different way, they would have told you that the parent function is the absolute value of x. So therefore, you should graph an f of x had the plus 5 inside the function, but then the minus 2 at the end of the function. The important part here is that if it's inside the function, it means left or right, and if it's outside, it's up or down. Which means the next transformation to learn, since the one we just did up there was about going left, is now we need to translate right. So in an equation, what causes a function to translate right? The answer is a number being subtracted on the inside with x. This minus 3 inside of the parentheses with x is what tells us that we need to translate, and this time it's right 3 because it's in there, inside those parentheses. And what's the parent function on this? On the parentheses is an exponent of 3, which means it's a cubic. And what shape does cubic graphs make? Remember, cubics make the up and down sort of S. So to graph this, I take my vertex at 0, 0. I'm going to go right 1, 2, 3. And now I have my new vertex. From there, I go right 1, up 1. And then from my vertex, I'm going to go left 1 and either up or down. If I look at my major points to plot, the cubic has left 1 going down 1 to make that S shape. So from my vertex, I need to go left 1 and down 1. And now I just make the right shape. Remember, I like to do it from the middle. I kind of curve up through that point. And then from the vertex, I'm going to curve down into that point to try to get the right shape. And finally, if they were to write it the other way, they would have said that f of x cubed, telling you what the parent function is. So then they'd want you to graph an f of x has a negative 3 in the parentheses, meaning telling you to shift right 3. So this example brings a few things together. First, what's the parent function? This one's the square root, because that's what that little symbol means right here, a square root. And what shape does the square root graph make? Remember, it's kind of the top half of a sideways U. And then what are the transformations that you see here? There's 2 of them, and the minus 5 means to translate right 5 is the minus. It's the opposite of what you think when it's in the function. It's under the square root with x. And then the minus 1 at the end means to translate down 1. So to make this graph from 0, 0, I'm going to go right 1, 2, 3, 4, 5. I'm going to go down 1, and then I'm going to put my dot. And I'm going to go right 1, up 1, and put another dot. And then for my third dot, if you look, the square root does not have a third dot. So from these 2 dots, we make our shape, which is the top half of a sideways U. And that's our square root graph. All done. All right, and just so that you can see it the other way, they might ask the question where instead they say, so the parent function is the square root of x. Therefore, we want you to graph f of x when it's going right 5, so minus 5 in the parentheses, and down 1, which is a minus 1 after the parentheses. And that's it. That's left and right. So using if-then statements, as well as these vocabulary words, explain what you learned in this lesson.